Alright everybody, how's it going? I am sorry I'm not in today. My son is sick, so I'm not going to be able to be there to help you out with your water balloon calculations. But I made this video to help you do that because we do need to launch our balloons on Friday. So let's take a look at your data and see how it makes some sense. So yesterday we went outside and we launched a balloon straight up in the air. And we measured the time of flight of that balloon. Let's use that time to figure out the exact launch velocity of the balloon. So because we launched a balloon straight up in the air, we need to use the big five. So when we use the big five, we have our five variables. We've got our initial velocity is what we're looking for, our final velocity, which is going to be absent, the acceleration, let's use minus 9.81 meters per second squared because that's a little more exact. Our time is what you measured. So use the average of the 3 times or whatever, how many times you had. Get rid of any outliers. So if there's a couple that are really close and there's one that's way out of there, don't use the one that's way out of there. All right, and lastly, we need our delta y. This word's a little different for everybody else as well. So remember how we stood yesterday. So you guys were outside, right? And we had one person on one side, one person on the other, and here's the water balloon launcher. When you pull the launcher down and let it go, obviously the balloon went up. So the balloon started actually in flight right here. So whatever distance you measured from here to here, this is going to be our delta y. So your group, you'll have to decide what that is. So I'll just make up a number now because I didn't do that part of the experiment. So let's just say it's 1 meter. I would use minus 1 meter for my displacement. I said I'd give you 3 things. There's 3. Ask for 1, and then there's 1 absent. So let's solve now for our V initial. We're looking for, V final is absent, so we've got delta y equals VI t plus 1/2 AT squared. So using this equation, we need to find our VI. So since I don't have a time here, let me just make up a time. So let's say my average time was, I don't know, 3.5 seconds. Okay, so let me use that time, and I'll use this data. So I'll use this imaginary data to find my initial velocity. So like always, I'm going to solve for VI. I'm going to isolate my variable. So I'm going to take this whole term and bring it over to the other side. I'll subtract it. So I've got delta y minus 1/2 AT squared equals VI times t. That is a minus sign. And then I'll divide both sides by t. And I'm left with VI equals delta y minus 1/2 AT squared all over t. All right, let me plug my numbers in. So I plugged all my numbers in. I've got my minus 1 meter. I've got minus 1/2 my A, which is gravity, 9.81 meters per second squared. My time is 3.5. I'll square that and divide it by the entire time of 3.5 seconds. So when I crunch these numbers out, I get a velocity of 16.88 meters per second. 16.88 meters per second. This is my initial velocity. Okay, this is the speed with which the balloon left the launcher. Okay, now let's use that information to figure out what to do next. So if we took, just like we did, we had our launcher straight up and down, right? So if you took all your measurements and you now did the same thing on Friday and instead launched it at 45, your initial velocity will be the same. So I had my initial velocity of 16.88 meters per second, okay? But now I'm going to do 45 degrees. The reason I choose 45 degrees is because this will give me the maximum horizontal range. Okay, but now, because we have an angle, we have to do things in the x direction and we have to do things in the y direction. So just like we've done, we got to figure out our VIY and our VIX. But if you know that if it's a 45-45 triangle, that these two sides will be equal. So let's just do the math real quick and show that they are equal. Since my VI in the x is my adjacent side, I'm going to use cosine. So I got 16.88 meters per second, cosine 45, which gives me a velocity of 11.94 meters per second. So if I do the same thing with the y, except I'm going to use the sine function instead of the cosine function. So I still got 16.88 meters per second. Now the sine of 45 degrees, and I do indeed get 11.94 meters per second. Okay, so these are the values I'm going to use now. Okay, I'm going to use this 11.94 and this 11.94. So the next step is to use this information and find the maximum horizontal range. Okay? Remember, if I want to find the range, it's going to be delta x is going to be my velocity in the x times time. Well, I already have my velocity in the x. It's 11.94 meters. But now I need to find my time of flight. You do not use the time you got yesterday. You have to calculate the flight using this information, because now our initial velocity in the y direction is 11.94. So let's use that information to find our new time. Okay, so since again it is it's a vertical problem, it's going to accelerate. It's going to be a big 5. I got VI, VF, A, delta y, and t. Move this up, and t. So my initial velocity is 11.94 meters per second. V final. So let's skip that just for a second and come back to it. A we know is minus 9.81 meters per second. So delta y. Now remember that when we launched, let's go back to our picture, right? When we launched this up before, we were 1 meter off the ground. So we had to use a displacement of 1 meter. So if you want to hit me in the foot, feel free to use minus 1 meter. But if you want to hit me 1 meter from the ground up, so like my belly button or something, you can use a displacement of 0. So I would, hope you don't want to hit me in the head, but I suppose if you want to do that, you want to use a positive displacement. But let me just go with a 0 displacement. Okay? So displacement of 0 meters. If that's a displacement of 0 meters, this is actually going to be a minus 11.94 meters per second. So I have 4 things. I can just try and find my time this way. I'll treat displacement as 0, which gives me to find time is v final minus v initial all over acceleration. My v final is minus 11.94 meters per second minus 11.94 meters per second all over minus 9.81 meters per second. This gives me a new time of 2.43 seconds. All right, last step. Let me put that up here. I've got 2.43 seconds. This gives me a maximum range of 29.06 meters. So what this means is I will be standing out in the field tomorrow. Okay, I will be standing out in the field tomorrow. There it is, my little wizard hat. And you'll be launching, and you are going to measure. We'll have some way to measure. I'll show you that tomorrow. And this will be 29.06 meters if I were using this data. So your information will be different, okay? And you're going to launch here, and you're going to launch, and you're going to hit me, and they'll be rejoicing, or you'll be sad because you missed. Okay, so that is how we do it. Please do this on using your own data. Once you have completed this, please work on worksheet 3. Okay, you can start doing number 2. Number 2 is a lot easier than you might think it is. Yes, a lot of the numbers are the same. That's okay. And then the other questions are a little more challenging. But please have your data, have your displacement ready tomorrow, because the more time we have to spend in class calculating these things, the less chances you will have to hit me. So I will see you definitely in class tomorrow. Have a great day.